Hey everyone, this is Ryan again. Noticing that we're having a little bit of challenges with some of these assignments. I've decided that I'm going to try to do example problems for each of the assignments that I'm going to be giving you to help you prepare for how to do the problems, because I know a lot of it comes down to the process that you use instead of just and you need to see the process to be able to understand how to do the problems. So what I have here is I have review exercise 3.4, which sort of tests on or test your skills that you learned from reading learning outcome 3, learning step 3. And you'll notice that most of the questions that come out of or come on assignment 3 come from learning outcome 3, learning step 3. So I'm hoping this is going to give you some background. Now, the first problem I'm going to be doing, problem number 1, we're trying to determine the probabilities for the standard normal random variable z. Oh, just a second, let me kick my light on here. Give us a little bit more light. I usually do these at night. I'm so thankful to be working in the daytime in my office to get some natural light. But I still also have a little bit of extra light that I add so that we don't have too many shadows or anything like that. So what we're doing here is we're determining the probabilities for the standard normal random variable z. Now, this is kind of like your training wheels as far as figuring out probabilities for continuous random variables. So you'll read a lot about continuous random variables in learning outcome 3, learning step 3. And mostly in this class we're working with random variables that are normally distributed. Now, the standard normal random variable are kind of like I said, your training wheels. This is where you learn how to figure out the probabilities using the standard normal table. And then when you take and look at an applied problem, such as maybe question 1 in assignment 3, where you're trying to figure out the probability that a person diagnosed with lung cancer lives for some amount of years and it's normally distributed, what you're always going to be doing is you're going to be finding a way to convert from that problem, which is very much an applied problem, to this sort of math problem dealing with the standard normal random variable. So let's try to do this first one, and these tend to be the easier ones. So I have with me a formula sheet, one of the ones you'd be getting on a test. It includes a standard normal distribution table, and this is what we're going to live off of when we're trying to figure these probabilities out, okay? This formula sheet's useful, and I'll point out where it is. You see, notice it has a number of different things, but for this stuff right here, we're mostly worried about the standard normal random variable. So let's go through this. Now, to figure this probability out, one of the neat things about this table is I want you to take a look at this right here. So what this is saying is this table is computing the probability that our random variable lives between, well, we'll put z, let's call this z with a little 0 beside it, call that z naught. Just to say it's some value, okay? So what this is saying is that if I were to say, let's say that z naught, and you've read about this, but I just want to reiterate this. Let's say z naught was equal to 1.5, well, you know what, 1.54, I guess it's close to the value we're looking for, but we'll use 1.54. Now, then, essentially what this table is giving you is the probability that z is between 0 and 1.54. So for instance, now the way to use this is, okay, down here, this is the first few digits. So the 1.5 is what we're looking for on this side. And on this side, we're looking for the 0.04, because if I were to add 0.04 together with 1.5, I'd get 1.54. So I look for 1.5 right here. I find 0.04 over here, and what I get is right here. So the probability that our random variable z lies between 0 and 1.54 happens to be equal to 0.4382, or in other words, 43.82%, okay? And so then this problem right here is almost the exact same. in the sense that we're figuring out the probability that z lives between these two values. Well, 1.5, and now it's 1.58, so I find 8 over here, and I go down, and I get 0.4429. So the probability here is just equal to 0.4429. Easy enough, eh? It gets to be a little trickier when things aren't from the 0. So anytime it's based around 0, things are pretty easy. And in fact, if I were to, let's just call this star. If I were to now say probability, you can kind of go in the reverse because everything's symmetric. You can say, well, let's say now z is between negative 1.58 and 0. So it would be like the opposite of what's going on here. This one's going out to here, but now we have that this side is the shaded one. This is where our z is living, or the probability we want to find out is in this area, and this would be now negative 1.58. Well, the neat thing about the standard normal table is that anytime you're based around 0, that's the way this table works. So it doesn't really matter that you're negative. This is going to be the same. This is actually equal to, and I'm just doing this sort of as notation, this is the exact same as if z is between, on the positive side, 0 and 1.58. So what I can then say is that this is just equal to 0.4429. It's kind of nice, hey? Okay, now B, on the same problem, we're trying to figure out the probability that z is now greater than 0.82. Okay, so this one, it's not as easy because it's not based around 0. Now we're saying we're trying to find the probability that z is bigger than 0.82. So I'm going to try to draw a graph, and this is always going to be helpful when you're figuring these things out. If you try to draw a graph, it's always going to help you out. Oh wait, my mic's not even on. Let's kick that thing on. Just 1 second. Should change how I sound a little bit, but hopefully for the better. Yeah, so now let's try to graph what this is going to look like. So we're saying that we're trying to find the probability that z is bigger than the number 0.82. Well, on the standard normal table, so I'm going to try to draw that, and pardon my drawing skills, I'm going to draw this standard normal distribution. And remember, with the standard normal, this point right here is 0. This should be symmetric. My drawing skills aren't the best sometimes, but it should be symmetric. And now 0.82 is going to live right here, 0.82. Okay, we're saying z is bigger than 0.82. So what we're trying to do is figure out the probability of stuff in this region. I'm going to get a different color to kind of help me with things. I just got some new markers, so just give me 1 second to do that. Okay, now what this is saying is, well, one of the neat things about the standard normal table is that the total probability, so the probability that z is greater than 0, or in fact less than 0, but for our purposes bigger than 0, is equal to 0.500. We'll just add some extra decimals in because it's a probability. So this whole side, the probability that our random variable is on this side, is always going to be 0.5, 50%. Now, one of the things is, because what we did up here was all based around a midpoint of 0 as well, what we were figuring out was we were finding this probability in here, where this was 1.58, or z naught was equal to 1.58. Okay, so we don't know that this table, though, does not give us the probability of something greater than a certain amount. But we can sort of use what we know to figure this out, because we know that the probability that z is greater than 0 is 0.5. And we know that we can figure out the probability of this region in here. And this region is the probability that 0 is less than z is less than 0.82. Okay, so from here, what we can do is we can figure this amount out. And this one's pretty easy. So right here, this is just equal to, and I just pull up my chart again, well, 0, so 0. So it's going to be in one of these columns because there's a 0 in the part that's bigger than 0. And then 0.82, so 0.8 and then 2. So it's actually going to be right here, 0.2939. So 0.2939. And then what this is saying is because graphically this whole probability is 0.5 and this one right here is just that region in there, to figure the probability of the stuff out of, above that, it's just this one minus this one. So notationally, what I'm saying is the probability that z is greater than 0.82 is just equal to the probability that z is greater than 0, so the probability that you have the whole, or that you're just above that line, above the 0 line, minus the probability that 0 is less than z is less than 0.82. And you can kind of do this for any of the ones where z's bigger than some number, but now we just plug the values in. So we get 0.5000 minus 0.2939. And I'm just going to, because I'm usually do these things in the dark, you never get to see my calculator, because I don't love the glare that it brings. But so here's my calculator. This is the wonderful TI-30XA, which many of you should have. So you just go 0.5 minus 0.2939, and I get 0.2061. So this is equal to 0.2061. So that's the probability that z is bigger than 0.82. Or in other words, this is 20.61%. Pardon me. Okay, so and they kind of, and they all get, any one of these questions, if it's not one of these ones where we're based around a 0, it's going to be this sort of level of, this is going to be kind of how we do things, is we're going to have to look at the picture and figure out graphically what we have to do. Okay, so let's look at number C, well, letter C, but it's like a number in some sense in our case. So now we're trying to figure out the probability that that z is between 1.32 and 2.76. Okay, so before we do anything else, I think we should draw the picture and try to see what we're working with. So I'm going to draw it out here, right? So I'm going to kind of try to walk you through how my brain draws these things. So here's my 0, right? Everything down here is negative, everything up here is positive. And now 1.32, now it doesn't really matter where you draw it because the picture is not as important as where everything is relative to the 0. So 1.32, it's positive, it's bigger than 0, so it's going to be maybe right here, 1.32. 2.76, we'll say maybe it's right here. Put a little arrow there, 2.76, because it's bigger than 1.32, bigger than 0. And then what they're trying to say is z is, this is 1.32 is less than z, but z is also less than 2.3 or 2.76. So it's going to be living in this region right here. That's where my z is going to be. So we're trying to figure out this probability right here. Well, same sort of thing as what we're doing here with subtraction, except now what's happening here is we have, it's kind of like we have the whole thing, right? We have 0 up to 2.76. That would be pretty easy to figure out, right? Because we can look on the table. And 0 to 1.32 would be pretty easy to figure out because we can also look at the table. The problem is we have just this region in here. Well, wouldn't it make sense that we could actually just figure out the probability up to here, so the probability that 0 is less than 0 is less than z is less than 2.76, and then from that we could, I'll get another color out to help emphasize my point. Okay, and from that we could take away just this little bit in here and it would give us our answer. Wouldn't that make sense? Now this area in here is going to be all the stuff between 0, or the probability that z lives between 0 and 1.32. So the probability that z is between 0 and 1.32. Okay, so really, so like I said, if I want to figure this out, I could take the probability up to 2.76, because that would give me all this region in here. And then from that, just take away the part that I don't want. I'll take away this little part in here, in the red. Okay, so let's just write that out notationally. So we have the probability. I'm going to try to save a bit of space because I don't want to have to flip pages right away. 3, 2 is less than z is less than 2.76. So this is going to be equal to the probability that 0 is less than z is less than 2.76 minus the probability that 0 is less than z is less than 1.32. Okay, so again, this is all, so again, we're trying to subtract here. So now we can look this up. 2.76. So 2.7 is right here, and 0.6 is right here. Let's just make sure I get this the right way. So I'm getting 4.9 or 0.4971. So I get 0.4971 right here, and then down here 1.32, 1.3, and 2. 0.4066. So 0.4066. Now let's get my handy calculator out. So I'm going to get 0.4971 minus 0.4066, and that's going to give me 0.0905. This is equal to 0.0905, which is, well, I'm not rounding, but this is 9.05% chance of being between these two numbers. So this is probably isn't the most accurate picture in the world, but again, it's always up to my artistic liberty. So let's do another. So D. Okay. D. So this is the probability that Z is less than negative 2.54. Now, so then I'll just draw a quick picture here because I think it's a relatively easier one. Well, yeah, I'll try to draw my best picture I can. Okay, so we're saying that we're trying to find the probability now that Z, so if this is negative 2.54, because the negatives are obviously below 0, we're figuring out the probability that we're above that. Well, the interesting thing here is that, again, whenever you're dealing with a negative, you can flip things and figure it out in the positive zone. So let's say this is 2.54. So actually, because everything, again, is symmetrical, this is going to be the exact same as the probability that Z is greater than 2.54. Okay? So then from here, if you remember, when we were figuring out the probability that Z is greater than some number, as in this question, we figured out the whole probability, right? The probability that 0 is less than, or Z is just bigger than 0 at all, is equal to 0.5. And then we subtracted off, I'll get my red pen out, and we subtracted off the probability that 0 is less than Z is less than 2.54, or that Z is between 2.54 and 0. This one's pretty easy to figure out, actually. So again, because it's based around the 0, 2.54, where's my 2.5? 2.5 and 0.4 or 0.04, it's 4945. 0.4945. So let's go back to what we were doing. So the probability that Z is less than negative 2.54 is equal to the probability that Z is bigger than positive 2.54. So then this is all equal to the probability that Z is bigger than 0 minus the probability that and actually you'll notice I put 0 less than Z here, and I put Z bigger than 0 here. None of that's really going to matter. It should all work out the same. It's just a different ordering, right? The important part, and I go back to my grade school teacher, when you're dealing with these inequalities is that z, the variable, is bigger than the fixed number 0, right? Same with this. 0 is less than the fixed number z, but really it's like z is still greater than 0. Remember, the bigger quantity is always the one that the alligator eats. If this was like an alligator and it was hungry, it wouldn't eat the 0, it would eat the z. So anyway, we're subtracting off 0 less than z less than 2.54. Okay, and this is going to be 0.5 minus 0.4945. So what I get is 0.5 minus 0.4945. And what I get as a final answer, 0.0055. Okay, I'm just going to rip this page off. Well, do I have enough room for the next one? I probably don't. Okay, I'll bring this page back if I happen to need it. But we're going to be on 3.4, review, continued. Didn't think I'd get to the second page. So this is going to be 1E. Okay, and now, so this one is going to be, this is a little bit more challenging than the others, but not too much more. So this is, now we have our z ranging over negative values because, you know, down to negative 1.22, so it could include things like negative 0.8 or negative 1 or negative 1.1, and ranging up to a positive value of 0.04. So, you know, things like 0.02, 0.03, things like that. So let's draw this out and figure out what we're trying to figure out. Okay. So we draw my picture, and you're always going to get extra marks if you draw your picture, okay? So I'm never going to give you, if you can draw this picture that I'm doing right here, and I'll just, any of these pictures, it doesn't have to be color coded, but if you can draw them, I'll give you extra marks for that. If you happen to get the wrong answer. If you get the right answer, of course, I'll give you full marks. Okay, so 0.04, and again, it's always up to artistic liberty. 0.04 lives over here. That middle point is a 0, and then negative 1.2, and this just is over here. So we're figuring out this whole negative region and this whole positive region. Well, actually, I mean, if you think about it, maybe I should even just shade it here. I'll put my red in here. Sorry about being kind of messy on this one. My hands are getting a little tired here. And then we'll put one here. Okay, so it's actually two regions. It's the region from 0 down to negative 1.22, and the region from 0 to 0.04. And you know what? I want to make a point, so I'm going to put a little, I'm going to actually change these to less than or equal to sign. They actually don't matter. As you read in the textbook, the probability of any particular value, any one individual value, because everything here is on a continuum, it's all continuous, the probability of any one value is going to be 0. So it doesn't matter if I put less than or equal to or just straight less than, because you might see it written this way, so I just don't want there to be any confusion. Anyway, back to our picture here. We have the probability that negative 1.22 is less than z, is less than 0. On this side, that's the blue stuff, and on the red, this is the probability that z is sandwiched between 0 and 0.04. Okay. Well, we remember from this example over here that whenever we're going from 0 down to a negative number, it's the same as going from 0 up to a positive number, right? When z's between 0 and a negative number, it's the same as when z's between 0 and a positive number. So in this situation, this means that the probability that that z's between negative 1.22 and 0 happens to be equal to the probability that z is between 0 and 1.22, positive. And so if I look on my chart, let's see here, 1.2, 2. So 1.22 right here, 0.3867 is what I get from that. So that's 0.3867. And now going to the red one, the probability, and this is an easy one, that, oh, whoops, getting sloppy here. Probability 0 is less than z, is less than 0.04. Well, this is just going to be, well, we can just look it right up on the chart. And this is extra easy because there's no digit on the first part, or there's no, digit bigger than 1. There's no digit in this, there's no number in this digit. And then we can just look at 0.04. That's going to be 0.01, or 0.0160. So it's equal to 0.0160. And then to figure this entire probability out, because we've got a negative side and a positive side, this probability that z is between 1.22 negative and positive 0.04 is just equal to the probability that z is between negative 1.22 and 0 plus the probability that z is between 0 and 0.04. And we've already know these two, right? Because you just add the two up, right? You take the negative side, you figure this whole thing out, you add it to this one. So this is 0.3867 plus 0.0160. Get my trusty calculator out. This calculator is our friend. It will help us through times of adversity. And then we have 0.016. And certainly statistics can be an adverse situation, but I'm here to help you through it. This is 0.4027, or in other words, 40.27% chance that our z lives between these two numbers. And last but not least, and this one's kind of more me just making a point, the probability that z is not equal to, uh-oh, my computer just closed up on me. No, we're good. 0.25. So this is the probability that, so this was kind of a bit of a trick question. And you remember in the last question that I made, or in this question, I said it didn't really matter that I included the less than or equal to sign because the probability that z is equal to any one value is 0. So what this is saying is this is the probability that z is not equal to the value of 0.025. Well, the probability that it's not equal to that value, if the probability that z is equal to 0.25 equals 0, and we remember the complement rule, right? The probability that z is equal to 0.25 plus the probability that z is not equal to 0.25 is equal to 1. Well, if this is a 0 plus the probability that z is not equal to 0.25 is equal to 1, well, 0 plus something equals 1, this is going to have to be 1. So the probability that z is not equal to 0.25 is equal to 1, or in other words, there's a 100% chance that that z is not equal to 0.25 because there's a 0% chance that z is equal to 0.25. Okay, so that's 3.4 review exercise question number 1. That's going to kind of lay the backbone for being able to do those problems. I'm still going to try to do some more problems from that same page. I just had to, I just like to sort of put them all in separate videos. So that's it for now. I'm gonna, and I'll be just keep watching for my the next video. Thanks. Bye bye.